Example 1, finding the volume of a sphere. Find the volume of a sphere with a radius of 1.8 centimetres. So remember, the equation for the volume of a sphere is 4/3 pi r cubed, where r is the radius. And we're told the radius is 1.8, so we just need to substitute that in. 4/3 times pi times 1.8 cubed. Then all we need to do is stick this in a calculator, and it will give you 24.43 to 2 decimal places. We should add some units to this. We were working in centimetres, and this is a volume, so it's going to be centimetres cubed. Find the volume of a cone with radius 3 centimetres and a slant height of 5 centimetres. So it's really important here that you notice it says slant height. That's not the vertical height. It's not the length of this dotted line. It's the length of this sort of diagonal line. So first, we need to find the vertical height, not the slant height. So to do that, we've effectively got a right angle triangle. You can see it's sort of in the shape, where this is our vertical height. We know the slant height is 5, and we know the radius is 3. So you can use Pythagoras with this, and you will get, well, you could do 5 squared equals 3 squared plus h squared. We want h on its own, so h is going to be the square root of 5 squared, take away 3 squared, which is the square root of 16, so 4 centimetres. So we now know that this side, the vertical height is 4 centimetres. From there, all we need to do is a third BL, so, or BH in this case, where B is the area of the base. The area of the base of this, it's a cone, is a circle. So we're just going to do pi r squared for that. So it's going to be a third pi r squared, where r is 3, times by the height, which we've just worked out to be 4. So that's 12 pi centimetres cubed. So the volume of the cone is 12 pi centimetres cubed, or if we want it as a decimal, 37.7 centimetres cubed to 1 decimal place. Example 3, finding the volume of compound shapes. The top of a cylinder is adjoined to a hemisphere. The radius of the hemisphere and the cylinder is 2 metres. The height of the cylinder is 6 metres. We need to work it out as separate parts. Let's focus on the cylinder first. Remember, a cylinder is effectively just a prism with a circular end. So the end of the prism is going to be pi r squared, where in this case the radius is 2. So we're going to do pi times 2 squared. For now, we'll just leave it in terms of pi so that we don't lose any accuracy. Remember, this is only the area of the end. To find the volume of the prism, or the cylinder in this case, you need to times by the height or the length of the prism. So 4 pi times by 6 in this case. So again, I'm going to leave it in terms of pi just for the sake of accuracy. From there, we need to work out the hemisphere, which remember is just half of a sphere. So it's half of 4/3 pi r cubed. So we know the radius is 2. So we're going to do a half times 4/3 times pi times 2 cubed, which, working this out, gives us 16 pi over 3. Again, leaving it in terms of pi so that we don't lose any accuracy. From there, the compound shape, CS for compound shape, is just these two added together. So 24 pi plus 16 over 3 pi, which is 88 pi over 3. And this would be in meters cubed because meters and meters, and we're working for a volume. So we are done, but if we want to give it as a decimal, this would be 92.15, and again, meters cubed. This is just to 2 decimal places. It does go on a little bit more, but we'll just leave it to 2 decimal places for now.